This project combined aspects of design, coding, and hardware to have a fully functioning weather station fish counter. The hardware in this project connected two shift registers in series, allowing 7 of the 8 pins on each shift register to be sent high and low signals corresponding to the segment being illuminated or not. One wire POV was used connecting the clock line of the 4017 decade counter to the Arduino digital pin. With every time a high signal was sent from it to the chip, a new one of the pins would receive a high signal illuminating a different digit. A reset pin was also connected to the chip, allowing for the loop to be restarted once all of the digits had been cycled through. Using this chip, the POV effect was obtained using only 2 pins on the Arduino instead of 4. This also saved lines of code as there is only one pin to be sent a high signal followed by a low signal to illuminate each digit instead of 4. Two PBNOs were used in this project, allowing for the value of the shift register and to increase by 1 every time the button was pressed and reset when the reset button was pressed. If statements were used to control the count on the button, and the pre-state value was set high when the button was pressed, allowing for the count only to increase by 1 every time the button was pressed. The BMP280 was used to display temperature in Celsius and barometric pressure in kilopascals on the LCD display. The unit kilopascals was displayed by dividing the reading by 1,000 and was chosen due to it needing only 2 to 3 digits to display accurately. For the code in this project, an emphasis was put on keeping it concise, as with all of the different aspects it could have easily become unnecessarily long. The statement blink digit was used to save 50 lines of code by simply calling on it every time a digit needed to be illuminated instead of restating the repetitive lines of code. For this project, the sunrise and sunset times must be manually written out in the code. A lot of thought went into the design elements of this project. For example, only the count button was mounted on the outside of the case. This would avoid the reset button accidentally being knocked, losing all the fish recorded on the fish counter. The power switch was also not mounted on the outside of the case. However, using the same hex wrench used to undo the bolts on the outside of the case, the power switch could easily be reached. This was also to avoid the power switch accidentally being knocked, resetting the count. An acrylic top was mounted to the case, keeping the wires neat and out of harm's way while still allowing the user to have a clear view of what was happening beneath the surface. A 3D printed case was also made to fit the final product, allowing for a very neat and relatively compact final build. I really enjoyed the process of making this project and believe that it helped to stretch my abilities in the world of coding and hardware, and I'm excited to put the project to use this summer.